Now let's use a combination of vertical and horizontal shifting to transform a base graph into our final graph that we have here. So I have a function h of x equals x plus 1 squared minus 3. Well, the first thing we must recognize is what is its base graph? And with time and practice, you'll be able to look at this fairly quickly and go, oh, its base graph is, and in this case, its base graph is x squared. That's what the basic function looks like with some shifting, some vertical and horizontal shifting. So we need to have an idea, what does f of x squared look like? Well, its basic graph of x squared is a parabola. So let's go ahead and do some of our shifting that we have that's going on. Well, the first thing that we notice is that within the function we have a horizontal shift of plus 1. That's within the parenthesis of the function x plus 1 squared. So I have a horizontal shift of 1. And remember, when it's a plus 1, it shifts the graph to my left. So I have the exact same graph. It's just shifted everywhere 1 unit to the left. So that's my horizontal transformation aspect of the graph. Now I have a vertical component to transform as well. This number tells me how far vertically do I shift a graph. And in this case, it tells me to vertically shift it -3 units. So I'll take this last graph I have, and everywhere I'm going to shift it down 3 spots. So there's my vertex, and now I have a graph that is shifted down 3 units. So just by knowing what its base graph or its base function is, x squared, I can go ahead and graph that function with fair certainty of x plus 1 squared minus 3 by taking the graph, shifting it left to the 1, shifting it left 1, and shifting the whole thing down 3 to get that particular graph. And that's finding transformations using horizontal and vertical shifting.